research involves the study of the variability and the predictability of climate over South America. In particular, southeastern South America, where Uruguay is, but also the rest of South America. And for that, actually, I have to study the oceans circulation, the atmospheric circulation, the interaction, and how these two components can add predictability for climate on seasonal, interannual to decadal timescales. Okay. Well, mathematics obviously is, at least for me, it's a tool. So we really need good mathematical tools to understand and to predict climate variability. So that includes good numerical models of the atmosphere and the ocean and the climate in general, as well as complex mathematical techniques from statistics or for like complex networks or machine learning that help us analyze the data better. Well, I think actually that when we want to look at disasters and risk, we really need many people with different capacities from different disciplines. And this was actually a very good way to try to meet with people from math, but also from physics, from meteorology, also from all the disciplines that are involved in the disasters. And again, I think that if you really want to improve the mitigation of disasters, the prediction of disasters, you really need to take a multidisciplinary approach, and that, you know, this kind of workshop helps in that. It has been very productive. The event so far, I think, has a great atmosphere, so there is a lot of interaction among the different people that has allowed that, you know, people to to feel very comfortable and express their ideas. And I think that's the best way to proceed. I mean, just to first have a brainstorming and then, you know, try to converge on some topic that most of us are interested in.
So so I'm a numerical analyst, and what that means is I take equations that govern physical processes, for example, atmospheric processes, things arising in climate, weather, oceans, this kind of thing, and I construct ways to represent these things on computers, efficient ways. So I'm quite lazy, I get the computer to do the work for me so that I don't have to do the hard work. So, well, it's got a lot to contribute. So mathematics is one of the underpinning sciences of all of them. All physical processes are governed by either mathematics or biology, right? I was told this. This is a quote from a famous scientist. I can't remember which one though. Anyway. Mathematics being the underpinning science, obviously things need to be understood from the ground up, so from the mathematical perspective, and it allows to give you great insight into what's going on in the world, in the atmosphere, things like this. So my research specifically comes in an area called numerical weather prediction. So numerical weather prediction being how can you efficiently represent the atmosphere on a computer? How can this be done in a fast and efficient way to meet some of the operational goals of big organizations? For example, in the UK, the Met Office or ECMWF, in Brazil, Semadine, and places like this. What motivated me to be at the workshop? So I kind of wrote the proposal for the workshop. So I guess I was motivated from that. So Giacolli, it was actually his idea. So the credit goes to him. He had some contact with some of the people in my working group in the UK, and said, look, there's this opportunity to write a proposal for a quite generic applied mathematics conference in weather and climate disasters, this kind of thing. And I said, yeah, that's a great idea. Let's do that. So then I did that.
That's great.
Very nice event. So this is a very nice conference. It is quite unlike other conferences that I've been to previously. It's very broad, very diverse. There's a lot of different people here with a lot of different specialisms, and so this is really good. It means I'm personally exposed to a lot of different areas that I wasn't aware of before, or maybe was aware of but didn't have a particularly good understanding. You get to meet people from these different fields who are able to even add insight to your own field, give you a perspective that you hadn't thought of before.
It's hydrological forecasting, and we give the runoff forecasting for the large reservoirs, and we give the for the short time period for the also the prediction using the hydrological model. Well, in my opinion, mathematics is fundamental. So it's a powerful knowledge that we need to have to improve our models, to improve our understandings for the forecasting, and it will, in my opinion, it will directly contribute for the disaster reduction. Well, during our work, we found many problems. Sometimes the forecasting is not satisfactory, and we want to improve our models. Perhaps we change the models. I mean, incorporate the use of the more complicated models. But mathematics gave a very so it's a very essential knowledge, so I think I cannot pass this opportunity. So that's the motivation. Well, wonderful. Because I heard many wonderful talks, and I think I had the opportunity to talk with the people in the top of the knowledge, and it's really fantastic to for me the specific case. So I just it occurred to me when I saw the fantastic talk. I just think that is it possible to use these techniques that those wonderful people developed just to use for our forecasting. It's very successful. This is a very successful workshop, in my opinion. Thank you.
So I am a probabilist, so I research random things, and in particular I'm really interested in random things over the sphere, which is an approximation of the Earth. And in particular I look at how different points of random things interact with one another, and how we can define that in a mathematically sensible way to hopefully improve numerical weather prediction in the future. So maths is essentially at its very core a way of taking something that everyone experiences every day and putting it into a model and quantifying it in a way that we can use a computer, and we can run things several times. So whereas disasters, when they occur, are tragic, when you run a disaster on a computer, you can run it hundreds of times over with no impact. The only thing you have to think about is the cost of the electricity, essentially. And if we can do that, you can actually end up saving lives by getting a good statistical picture of what's probably going to happen if and when they do happen in the real world. I was very kindly invited. I am a student on the MaTH of Planet Earth Centre for Doctoral Training. So when Tristan had some places for British students to come along, he kindly invited me as one of them, knowing that I'd be interested in seeing a different perspective. A lot of what we see as part of MPCDT is very much UK and Europe based, which is understandable, and it's absolutely fascinating to see a Southern Hemisphere and Brazil based perspective on things, because it's a much larger country with a very different climate to the UK. So seeing the difference in perspectives and being able to talk to people whose experiences both mathematically and meteorologically are very different to yours is really fascinating. It's been fantastic. I have spoken to people that I would never have otherwise got the chance to speak to, probably in my whole career, let alone during my PhD. The country is beautiful. I'm having a wonderful time. The weather is much better than it is in August in the UK. I've learned a lot. I've learned some things that are not mathematical that I wouldn't have learned otherwise. And I've also learned some really good maths which will feed directly into my PhD, despite this being a workshop more about climate than necessarily about what I research on a day-to-day basis. So generally it's been a massive success so far.
I do research on atmospheric science, and my interest concerns about Granger causality. My line of research concerns about finding links between compartments of the atmosphere. Okay, so one example that I can give to you is if the Ocean Pacific is causing some action on the monsoon here in the South America, or otherwise. My motivation is to make some networking with the researchers here at INPE, mostly because of my my advisor, who is Pedro Dias at USP, at IAG, who knows most of the researchers at INPE, and I knew that some of the researchers like Haroldo was going to be here, and I wanted to talk to him. I wanted to see some of the talks that was going to happen here. I wanted to participate of the discussion group. The event is happening as I expected. It is exceeding my expectations. The organizing committee, I want to congratulate the organizing committee for the event, and I want to sincerely see more events like this.